Okay, the second note sheet of this unit is all about radicals, and really the beginning part should be a review from your junior high math, and then we'll get into a little bit more challenging simplification questions. So just a reminder, so 3 squared is 9. Since 9 is the square of 3, we say 3 is the square root of 9. So just be careful. Sometimes people get mixed up between square root and square. So when you square a number, you're raising it to the exponent 2. When you're square rooting, it's the square root symbol. So you're looking for that base of this original exponent. Okay. Notice here how it has a little 2. Because square roots are so common, we don't normally show the 2. It's understood. So if there's no index there, then it's a square root. We put it there just to see the pattern. Next one, 3 cubed is 27. So since 27 is the cube of 3, we say 3 is the cube root of 27. Okay, 3 to the 4th is 81. Since 81 is the 4th power of 3, we say 3 is the 4th root of 81. So when it was squared, exponent 2, exponent 3, there were special words for that. Exponent 4, no special words. It's the 4th power or the 4th root. Here, 3 to the 5th. So what's that? 243. And that since 243 is the 5th power of 3, we say 3 is the 5th root of 243. So here, 3 is the answer when you take the 5th root of 243. Okay, so just some terminology. When you have a radical like this, the little number in really close to the radical sign is the index. Sometimes you even put it up a little bit higher. Just be careful. Don't go, oh, 4th root of 81. That's kind of lazy, right? That's a big 4. It's kind of not sure. Is that 4 root 81 or is it 4th root of 81? That's what it should be, okay? But it's a little unclear, right? So make sure you sometimes have to have nice, neat writing when you're doing math. Okay, the number underneath the radical sign is called the radicand. Obviously, that's a radical sign, the symbol part, and the index. The most common index used is 2, so I just talked about that. And to save time, we often do not write the index of 2. So if no index is written, then it's understood to be square root index of 2. So we're going to complete the following table. I'm just going to move this up a little bit. So 5th root of 32, so the index is 5, the radicand is 32, we say 5th root of 32, and what is the answer? What's the meaning of that? It's whatever number is raised to the exponent 5 to get 32, so it's 2. So a number raised to the exponent 5 to get 32 really is 2. That's your answer. 4th root of 16 here, so 4 is the index, radicand is 16, 4th root of 16. So a number raised to the exponent 4 to get 16 is 2. Just happens to be the same value there, okay? Index of 3, radicand is 125. So this is the third root. Really, we say cube root of 125. It has a special name. A number raised to the exponent 3 to get 125 is 5. Okay, 5 cubed is 125. Here, no index, which means it's 2. Radicand is 49. So here we use that special word, square root of 49. So a number raised to the exponent 2 to get 49 is 7. 7 is the square root of 49. So these all worked out nicely, okay? Let's look at the next part. So now we're going to concentrate on square roots. Actually, before we do that, I'm going to quickly go back here and let's take a look at your calculator, and I'll show you where you can find those keys in case the calculator is new to you. So if you have a TI calculator, if you have a Casio, it's very similar. Once I'll have to help you if you have a Casio if you're not sure, but once you do it once, you'll be good to go. Same thing with this. So square root for all calculators is usually on the calculator, and it's often the second function of x squared. So if I start with square root of 49 there, that would be second x squared, which is square root of 49. Okay, enter. Some older versions of the TI won't have that root symbol going all the way across. It'll just have a root, may open a bracket, put 49, close the bracket. Okay. Cubed root, so let's kind of go from bottom up. So cubed root isn't on the actual calculator. In a TI, you go to Math, and you'll notice here, just on the very first screen, you have cubed. Okay, if you wanted to cube something, then you have cubed root is 4. So if we go to 4, then again, on this newer version of a calculator, it actually can show that little index up high. On older versions, it'll kind of look like it's a number in front. So just be aware that that means cubed root. And then in this case, I'll enter 125, cursor out, enter. If it opens a bracket, just close the bracket. Not that it matters with one number, but once you start doing other operations, it's really important to make sure that you're not taking the root of other things. Then fourth root, so if you go Math, you'll see that there is no fourth root. So there's the xth root. So enter on that, and you'll notice in this newer version of the calculator, it's flashing on the index. So now we can put 4, and there's an arrow key. We need to get out of there. So arrow to the right, and then what's that, 16, and arrow out. Okay, that's a newer version of the TI. Older versions, you have to put the index in first, then you go to Math, then you go to X root, and it will show it for xth root. So you know the 4 is going in for the x. Because I have the newer version, if I do it in this order, it actually puts it in right away. But as long as you have 4 xth root and then put the 16, you're good to go. And then same with the 5th root. Okay, so that's how you can do higher roots other than square roots, in case you weren't sure how to find that on your calculator. Okay, square roots. If x is the square of r, then r is the square root of x. That is, if r squared equals x, then r is the square root of x. Some numbers have a square root, but there are some numbers for which you cannot take the square root. What numbers do not have a square root? Okay, so what numbers do not have a square root are all, well, for sure, negatives, you can't, right? And then any non-perfect square. So what numbers do not have a square root? Non-perfect squares. And negatives. So you can take the square, so I'll put that in brackets because a negative will never be a perfect square, so that kind of gives it away. But you can take the square root of only a positive number or 0, so that's why we said no negatives. That is, the root of x exists only if x is greater than or equal to 0. Okay, so we've talked about domain and range in this course, so really kind of gets into that, right? You have to have x, and if this was a function y equals root of x, then your domain would be x has to be greater than or equal to 0 in order to have a graph. Okay, so now going back to that definition up here, right? If we solve an equation like this for r, technically there's two possible answers. So if x squared equals 9, so here's an example, what are the two possible values of x? Well, remember, the values of x that solve this equation, you have to be able to substitute them in to satisfy it. So 3, obviously, 3 squared is 9, but don't forget, negative 3 squared is also 9. So how many square roots does a positive number have? Well, it has here, when you think about square roots, we're always taking the positive. So there's 2 possible here, but this is really important to remember, okay? A positive number has a positive and a negative square root, but root of x always denotes the positive square root, okay? And that's always what you have to take. So anytime, so you get 2 here because you're actually solving this equation, which is a degree 2 equation. So you get 2 solutions. Okay, so you'll learn more about that as we go on in math, solving degree 2 equations. Right now, from junior high math, you probably only solved linear. Just be aware. So anytime we ask you to take the square root of 9, you're just going to get 3, not plus or minus 3, because this is telling you this is positive. Okay. And 9 comes from 3 squared or negative 3 squared, but this is just a number here. It is not a variable. Anyway, I'm kind of dwelling on that, but sometimes students start putting plus or minus in. You get a little bit mixed up. Okay, so really important to know at least up to 10 squared off by heart. Okay, you may not know all of these afterwards, but we're going to fill them in because it'll help us with some of our work. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. You've been doing this for a few years. I think squaring numbers started in grade 7 or 8. So hopefully you've got this mental math down pat. Now, after maybe you don't remember, I sometimes have difficulty with these two. And in any case, 121, 144, 13 squared, let's check. 169, I think. Yep. Okay, and then 14 squared. For whatever reason, I kind of have to check. 196. So 169, 196. That's a good way to remember it. The 2 digits switch around. And 15 squared is 225. Okay, then powers of variables, which you may not have done as much of. So when you square x, you just get x squared. That really doesn't change, except we're getting rid of the brackets. So it's more like an order of operations. X squared squared is x to the 4th. X cubed squared is x to the 6th. So this is back to the powers, and this is going to help us with the powers and simplifying all that kind of stuff. So we're just squaring these, and you'll notice that the exponent on all of them, they're even numbers because you're squaring. And remember, raising a power to a power, you multiply the exponents. Okay, so a power is a perfect square. Take a look. These were all perfect squares, right? We were squaring these. We were just increasing the power on the original x by 1 each time, and then squaring all of them. Notice that the exponent is even. To find a square root, divide the exponent by. So remember, square root gets you back to what's in the brackets. So 10 divided by what gives you 5? 8 divided by what gives you 4? You're dividing by 2. So that's the easy way of remembering how to take the square root of variable power. Okay, so next part here. Let's look at cube root. So x is the cube of r, then r is the cube root of x. So again, starting with the basic, if this is your equation, then r is cube root of x. What's nice about cube roots is you can take the cube root of a positive and a negative. Okay, so let's think about this. So cubed root of 27, think about what cubed gives you 27? 3 does. Okay, cubed root of negative 64, well, 64 is 4 cubed, but this is negative. So think about negative 4 cubed. Negative times a negative times a negative is a negative. So this would be negative 4. Okay. You can take the cubed root of any number. The cubed root of a positive number is positive, and the cubed root of a negative number is negative. Obviously, you can't. So back here, let's just go back to this square root one. Some numbers have a square root, but there are some numbers for which you cannot take the square root number. So here, when I said non-perfect squares, I was kind of meaning that to get an actual natural number value, you had to have a perfect square. But really, we cannot take the square root of negatives at all. We can take the square root of non-perfect squares, but it's not going to give you a natural number. So just be aware, maybe that was a little bit confusing when I was saying that. Okay. Here you can take it of anything that lists the first 10 perfect cube numbers. Again, some of these I always say for sure up to 5 cubed, and then for sure 10 cubed. You may not, I don't know all of these off by heart. We tend not to get too big of a number for some of these. So 1 cubed obviously is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 243. I always have to check. Oh, no, sorry, 216. 7 cubed is 343. Got those kind of mixed up. 8 cubed, so that's going to be, so 8 cubed is 512. 9 cubed is 729, and 10 cubed is 1,000. Okay. List the first 10 perfect cube powers. It's not the first 10, it's 5. So x cubed is x cubed. Power of a power, you multiply the exponents. Take a look at those exponents. Okay, the power is a perfect cube if its exponent is a multiple of 3. Okay, so to take the cubed root of a power, you divide the exponent by 3. Now, if you cannot divide by 3, then we have to simplify the radical, and we're going to talk about that in a bit. Okay, you don't just leave it as a decimal exponent. Okay, higher roots. So number 16 is the 4th power of both 2 and negative 2, since 2 to the 4th is 16. Negative 2 to the 4th is 16. The radical 4th root of 16 represents the positive 4th root of 16. So you take 2, you never negative 2. Okay. First 5 perfect 4th powers. So that's 1, 2 to the 4th. So sometimes I think about that, well, that's really 2 squared. So 4 squared is 16. This is really 3 squared. 9 squared is 81. 16 squared is 256. 25 squared is 625. Okay, and then that's x to the 4th, x to the 8, x to the 12, x to the 16, x to the 20. Then since 2 to the 5th is 32, the 5th root of 32 is 2. Similarly, negative 2 to the 5th is negative 32. So that's the only way you'd get a negative, is if the radicand's negative there. Like cube roots, you can take the 5th root of any number. Fifth root of a positive is positive, fifth root of a negative is negative. So again, powers of 5 here, so 1. So if you think about 2 to the 4th is 16, 2 to the 5th is 2 times 16, which is 32. 3 times 81 is 243. 4 times 256 is 1,000, what is that for? 1,024. And then 5 times 625, my brain is a little slow right now. So 5 is, yeah, 3,125. Okay. Okay. And then x to the 5th, x to the 10, x to the 15, x to the 20, x to the 25. Okay, all those exponents are multiples of 5. Okay, so if you're taking the fifth root of x to the 25th, you divide 25 by 5, divide 20 by 5, 15 by 5, and so on. So summary here, a radical is an expression in the form the nth root of x, where n is a natural number. The square root symbol is called the radical symbol. Oops. N is called the index, and x is called the radicand. If the index n is something, then the radical exists for all values of the radicand. Okay, so the radical, this should be the radical nth root of x exists for all values of the radicand x. So that means that's for an odd index, means you'll always be able to take the root of it. Doesn't matter if it's positive or negative x. If the index is even, then the radicand x must be positive. Well, actually, must be greater than or equal to 0, because it can be 0 as well. If n is even, then the expression nth root of x represents only the positive root. Okay. All right, next part, simplifying. So, radical is in simplest form if the following statements are true. The radicand does not contain a fraction or any factor that may be removed. The denominator does not contain a radical. So these here that have a radical in the denominator, even though that's underneath as a fraction, it's still the same as, so this here is the same as root 3 over root 5. And so you have a radical in the denominator. So that's not in simplest form. We'll learn how to simplify those a little later. If there is a factor of the radicand that is a perfect square, then it's not simplified. So here, for example, 24, if you think about 24, that's the same as 4 times 6. Well, 4 is a perfect square, so this can be simplified. So if you think about simplifying fractions to lowest terms, simplifying, you're looking for a common factor between numerator and denominator. With radicals, you're looking for a factor that's a perfect square. So it's kind of similar in that sense. Okay, so let's practice some of these. So express as a simplified mixed radical. Okay, so that means you'll have a factor out front and then a radical. State the values of the variable for which the radical is defined for these ones that have variables. So starting with 72, and this is where you might want to have your list of perfect squares in front of you. All right, so you want to look for your biggest perfect square. So if I just write some of these out, so 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Okay, so I want to look for the biggest perfect square that's a factor of 72. If I say 4, that's a factor, but it's not the largest one. So then you'd have to simplify again. So I always look at my list. 72 is in here. So you just start checking these numbers underneath. Okay, and with a calculator, check by dividing. So if you're not sure, like you might say, okay, well, 72, let's divide by 36, because 49 is not an even number. So I want to choose even numbers. And you're done. You got it, right? But if you said 72 divided by 4, if you went from the other way, you'd have 18. So you'd have to still have root 18 that you'd have to simplify. So always start from the right and go left. So you can show this. Just to start, I'm going to show it as that factor. And then I circle, this is what I like to do when I'm learning this stuff, is circle the the perfect square. Okay, root 30, so root of 36 is 6. So I think about it as the symbol is like the roof of your house. And 36 is the perfect child. Perfect child gets to go out on the weekend. So when the perfect child goes out, that 36 is gone from underneath the roof, and they dressed up. They're looking like a 6. Okay, so 36 becomes 6, and then 2, the non-perfect child, has to stay home on the weekend. Okay, and that's a big 6. It's not an index. So next one, 150. Anytime you see a 0, you want to look for something with a 0 or 5. So 100 doesn't go in, but try 25. It does. So 25. Oh dear. Sorry. So square root of 25 times 6. Then perfect child here is 25. So looks like a 5 when he dresses up. 6 has to stay home. Is just means 5 times root of 96, just like this number here, 5 times root of 6. So we leave that. Root of 96, you want to look for the biggest perfect square. So got to be even. 64 won't go in. 36, well, we just did 36 times 2 and gave us 72, so that doesn't work. So I'm going to try 16. So 96 divided by 16 is 6. Works. And in high school, we sometimes use a dot, not like a decimal in the middle. It means multiplication, and it's a little less confusing than an x, because sometimes that looks like a variable for multiplying. Okay, so 16 is your perfect square. 16 gets to go out on the weekend. And so here it'll be 5. And sometimes this is what I do. I put in brackets what I get when I simplify this. That's going to be 4 root 6. And then I multiply the numbers out front. That's going to be 20 root 6. Now, you don't have to use brackets. You could go 5 times 4 root 6. Really, these will be 1-mark questions. You can go straight to 20 root 6. Okay. Now, some variables. So this is a square root. So remember, if you look back in the notes, it says to take the square root of a variable power, you divide the exponent by 2. Okay, so that's just going to be x to the 5th. Okay, you can't take the square root of 10. It's not, 10 is not the radicand. It's x to the 10. So if you could check by squaring that back. So x to the 5th squared, do you get x to the 10? Yeah, you're good. State the values of the variable for which the radicand is defined. So here, because we are raising x to the exponent 10, it doesn't matter if x was negative or positive. It will end up being a positive underneath, and so you can take the root of it. Okay, so x can be an element of the set of real numbers. Just be aware here, though, that if this is always going to be a positive value once we've taken the positive root. So really, sometimes you'll see this shown as x to the fifth, or in absolute values, or x to the exponent 5. So just be a little bit aware of that. Okay, but this is what it asks you, just to state what x is defined for. Here, square root of y to the 25th. Don't get confused here. It is not y to the 5th, right? If you said y to the 5th, this would be x to the 5th. How are those the same with a different exponent? Square root means you have to divide y by 25, which you can't do. So this is what you have to do for these ones. If you have to split up into two factors, just like you did here with the numbers, into the biggest perfect square that's a factor of y to the 25th. So basically, you want to look at the largest even number that's less than 25, which would be 24, multiply by y. Okay, so that's the same as this, right? Y to the 24 times y is y to the 25th. Now, y to the 24th is a perfect square. It gets to go out on the weekend. What is it worth? It's worth y to the 12th. And then this y has to stay home. Okay, here, in order to take the root of y to the 25, we can't have this being negative. So y, in this case, has to be greater than or equal to 0. That's what it's defined for. Okay. So here it just has two variables. So again, odd number. So I'm going to show this. So think of a to the 11. Biggest perfect square that's a factor of a to the 11 is a to the 10. It's always one less, right? Then an odd number is an even number. So a to the 10 times a times b to the 6. Perfect squares then are a to the 10 and b to the 6. Okay, so square root of a to the 10 is a to the 5. Square root of b to the 6 is b cubed, and this a has to stay home on the weekend. Now, what are your what definition for a here? A needs to be a to the 11 needs to be positive, so a has to be greater than or equal to 0. But b could be anything. Okay. And again, if b is anything, really, you might see this with absolute values. Next one, now we've got numbers and variables, so we're going to do it all at once. So here, big radical, biggest factor of 20 that's a perfect square is 4, so 4 times 5. And then b to the 9, 9 is not a even number, it's a perfect square, but it's an exponent, so you cannot square root 9 and get 3. So we need to split this up into the biggest perfect square that's a factor, so b to the 8 times b, and then c to the 4 times c. Okay, I haven't changed anything, I've just factored it. Now my perfect squares are 4, b to the 8, c to the 4. Okay, and so that'll be 2. Square root of b to the 8 is b to the 4. Square root of the c to the 4th is c squared. And you're left with 5 has to stay home, b has to stay home, c has to stay home. And for this, we need b greater than or equal to 0, and we need c greater than or equal to 0. We need them to be positives. Okay, then cubed roots. So maybe I'll just put that underneath here. So some of your cubed roots. So 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. We might need more, might not. Okay, cubed root of 8. So, cubed root of 40. The biggest perfect square that's a factor is 8, or perfect cubed, I should say. So here, I'm going to split this up into 8 times 5. And then I'm taking the perfect cube, gets to go out on the weekend. Okay, and so then that's worth 2. Cubed root of 8 is 2. And we're left with cubed root of 5. Be very careful. Make sure you do not forget to write down the little 3. If you say square root of 5, so this is very common, students do this. You got some right numbers, but you forgot the 3. That has a very different value. So let's take a look at your calculator and just see sometimes if you need a quick check on your work. So your calculator and the TIs will not simplify a radical. You're not allowed to have a calculator on a test that simplifies radicals for you. There are some out there, right? But you can't have that on a test. So, but what you can do is compare the decimal form. So if I go math and then cubed root of 40, and then let's say I thought it was 2 root 5. I know right away that I did something wrong. So then I go back, oh yeah, it should be 2 cubed root. So 2 cubed root 5. And then those match, right? The original and my simplified. So that's a way to check. Okay. Cubed root of negative 500. So does 125 go into 500? Hopefully you know it does, but let's just check. 500 divided by 125. It does 4 times. Now notice this is negative. So when I show this, I want to make it as simplest as possible. See if you can take a negative out. Don't leave a negative in there. So I'm going to show this as negative 125 times 4. And then my perfect cube is this. And that's going to be equal to negative 5 cubed root of 4. Rather than leaving, you could leave a negative 4 underneath there, but that's not simplest form. 576. So do I have to go higher in my perfect cubes? Let's go 576 divided by 64. And I get 9. And 9 is not a perfect cube. It's a perfect square, but not a perfect cube. So that works, right? 64 is the biggest perfect cube that's a factor. There's a negative number out front that just means multiplying. So negative 8 cubed root of 64 times 9. And then my perfect cubed is the 64. So this is going to be negative 8. Again, I use brackets, so that's going to be the negative 8 times 4 cubed root of 9. And then multiply those integers, and I get negative 32 cubed root of 9. Okay, next one is variables. So remember to take a perfect cube, to take the cubed root, you have to have a perfect cubed as a factor. So that means 17, check and see if it's a multiple of 3. Well, it's not. So you have to show this in factors. What's the next lower exponent on m that is a multiple of 3? So that would be 15. Okay, and basically, you know, if you show this, 2 is less than 3. If you got something bigger than 3 here, then you didn't get the right number. So that is in factored form. This is your perfect cube. So to take the perfect cube, remember you divide 15 by 3, and so that is m to the 5th. And then we're left with cubed root of m squared. Okay, and then cubed roots, m can be anything, all real numbers. This is your little symbol, remember, element of. Cubed root here, negative 108. So hopefully you know this, but if you're not sure, check. 108, I'm going to divide by 27 because I know 9s go into both of them, and I get 4. So that's good. It's negative, so I'm going to have cubed root of negative 27 times 4. Then my variables, so 7 is not a multiple of 3. Next lower is 6. So p to the 6 times p. And then r squared I can't do anything with. It's already lower than 2. All right, so then my perfect cubes there and there. And so cubed root of negative 27 is negative 3. Cubed root of p to the 6 is p squared. And cubed root of 4pr squared. Here, p can be anything, r can be anything. Take the cubed root of anything. Okay, then fourth roots. So, fourth root of 64. So let's write them down here. So 1 to the fourth, 2 to the fourth is 16, 3 to the fourth is 81, 4 to the fourth is 256, etc. So 16 goes into 64 4 times. And then fourth root of 16 is 2, and we're left fourth root of 4. Okay. Fourth root of 162. Well, you can see 81 goes into that. So that's fourth root of 81 times 2. Perfect. Fourth power. So that's going to be 3, fourth root of 2. Next one, negative 2 goes out front. I see a 5 there, so I didn't do 5 here. So 5 to the fourth was 625. Okay, so let's just check. 1,875 divided by 625 goes in 3 times. Okay, and then fourth root. So negative 2, and that's going to be 5, fourth root of 3. And so that simplifies to negative 10, fourth root of 3. Next one, fourth root of 512. Okay, so 512, if you look, 256 doubled is 512. So that's going to be fourth root of 256 times 2. And then your variables. So 23 is not a multiple of 4. Next lower multiple of 4 is 20. So that's going to be 20 times m. So m to the 20 times m cubed. That's a fourth power. That's a fourth power. So that is, that simplifies to 4. This, you divide 20 by 4 is 5. And then you're left with the fourth power of 2. Has to stay home on the weekend, and m cubed has to stay home. Here, we would need m to be greater than or equal to 0, so that we'd have a positive underneath there. And then all variables here. So factor them. So next lower multiple of 4 is 8. So a to the 8 times a. B squared, can't do anything to it. C to the 7 would be c to the fourth, c cubed. Okay, next lower multiple of 4. So now that's a fourth power, and that's a fourth power. This is, let me do a little, this is not a fourth power. Okay. Let's fix that up. Okay, so then divide 8 by 4, you get 2, so that's a squared. 4 divided by 4 is 1, so that's c, and then 4th root of ab squared c cubed. In this case, it's a 4th root, so a has to be greater than or equal to 0, and c has to be greater than or equal to 0, and b could be anything. Okay. Then list out some of our 5th roots. So 1, 2 to the 5th is 32, 3 to the 5th is 243, 4 to the 5th is 1024, etc. So here, 5th root of 246, I notice that 243 doubled is 486. So I can do that right away. And then 5th power is this. It gets to go out on the weekend. So that's going to be worth 3, 5th root of 2. Then 5th root of negative 128. So 32 goes into that 4 times. So that's going to be, I'm going to put negative 32 times 4. 5th root of negative 32 is negative 2. 5th root of 4. Then 6 is a factor up front, 5th root. So probably, I didn't put 5 to the 5th here, but remember 5 to the 5th is 3,125. And so that doubled is 6,250. So 3,125 times 2. Okay. 5th root of that is 5. And then multiply those together. Okay, and then 5th root of x to the 14th. So 5 doesn't go into 14, so we need to split it up. Next lower exponent that's a multiple of 5 is 10. So now 5th root of x to the 10, you divide 10 by 5 is 2. So that's x squared. And x to the 4th has to stay underneath the radical. And here we can take the root. It's a 5th root, so it can be any value. Then 96. So what's 32 times 3 is 96. C to the 9, so 5, that would have to be c to the 5 times c to the 4. 5 doesn't go into 16, but it goes into 15, so d to the 15 times d. And there's your 5th power, 5th power, 5th power. So 5th root of 32 is 2. 5th root of c to the 5 is c. 5th root of d to the 15 is d cubed, with 5th root of 3 c to the 4th d left. And again, they can be all real numbers because it's the 5th root. All right, so that was simplifying. Now, expressing as an entire radical is just vice versa. You're basically, whatever the radical is, whatever the index is, you use that to take any number or variable out front to put it back in. So basically, think about my analogy of perfect square gets to go out on the weekend. So in this case, this would be 25 times 2. Perfect square gets to go out on the weekend is worth 5. So to go back home, he's worth 25. Okay, so here we basically square. 5 is 25 times 2, and then that's 50. Okay, so you're unsimplifying. We're expressing as an entire radical. Erase that. Next one, I leave the negative out front. If it's a square root, I leave the negative, and then 4 gets squared, which is 16 times 3. So that's negative root 48. If I squared negative 4 and put it back in, it would still be positive 16, and it'd be root 48, and that would not have the same simplified value. So you have to leave that negative out. If it was an odd index, then you could do both, either or, but this you have to leave out. Here, this is 3x times root of 2x. So really, you are squaring, I'll show it the long way, 3x multiplying by 2x. So that's 3x squared times 2x, which is root 18x cubed. Okay, that's the long way. You can go right to 18x cubed. Here, this is going to be, so 4 squared is 16. X cubed squared is x to the 6 times 5. And so multiply the numbers together. That's going to be 90 x to the 6. Same thing here, leave the negative out. 8 squared is 64. 8 to the 4th is a to the 8 times 7a. So 64 times 7 is 448, and then a to the 9. Okay. Next one has cube roots. So this is going to be 6 cubed underneath. So 6 cubed is 6 cubed is 243. Or sorry, 216 times 5. So then multiply those together, and that's your entire radical. Make sure you keep the little index of a 3. If you drop it, then it's really a square root. It doesn't have the same value. Now with the negative here, we can leave it out, so you can show it either way here. So 2 cubed is 8. So this would be negative cubed root of 32, or cubed root of negative 32. Because it says show as an entire radical, then this is the way for a cubed root. I'm going to show it because it is entire. Here we can't bring that negative in there. Okay, it would change the value of it, so we have to leave it out. Here we have an option, so as an entire radical, I'm going to put it in. Okay, so just be aware of that. Next one, cubed root. So 3 cubed is 27. X cubed times 5. Then 27 times 5 is 135. X cubed. Next one is cubed root. M to the 4th cubed is m to the 12th times m squared. That's m to the 14. Then again, you can leave the negative out, but because we want to do it entire, I'll put the negative in. So negative 2 cubed is negative 8. Y to the 5th cubed is y to the 15 times 7y squared. So that's negative 56 y to the 17. Okay, and then express in ascending order. So remember, I always think of descending first. Descending is going down. Ascending is going up. So that's a word that you do need to know. Okay, so increasing value. But if you forget, then think decreasing is going down. You know that. Ascending, we use decreasing a lot more in just everyday talking than ascending, I think. In any case, so here, take a look at the index on each of them first of all. Then so they're all cubed roots. Then take a look at the radicand. They're all the same. So that all then you have to do is look at the coefficients. So what's the smallest coefficient? 3. Then the next smallest, then the largest. Okay, so that's pretty straightforward when they have the same index and same radicand. Or B, if you take a look here, all the index of each root is 2. They're all square roots, so they're the same. The radicands are different, but the coefficients are all the same. So really, you don't even need to think about the coefficients. Now, you look at the radicands and look at increasing order of those. So that would be, still include when you list them, the 4, because that was in the original. So 4 root 5, and then 4 root 6, and then 4 root 7. Okay. In C, take a look here. Now, they're all square roots. The radicands are different, and the coefficients are different. So in this case, I would, again, trying to do this without a calculator, I would show them as entire radicals. So, so I'm not going to, well, yeah, I'll put equals. So 9 squared is 81, times 2 is 162. 5 squared is 25, times 6 is 150. 8 squared is 64, times 3 is, what's 64 times 3 is 192. So now the middle one is the smallest. So 5 root 6, right? And then 9 root 2, and then 8 root 3. Next one, they're all cubed roots, so that's good. The radicands are all different, the coefficients are all different. So very similar to the last one. Let's show them as entire radicals. So 3 cubed is 27, times 5 is 100, oops, is 135. 2 cubed is 8, times 15, so 80, so that's 120. 4 cubed is 64, times 2 is 128. So in order, the middle one is the smallest, then the last one, then the first one. Okay. And then here with this one, there's no way you can change a cubed root to a fourth root at all. You could do something in terms of fourth and square root, but you can't do this. So this one, I would just use your calculator. For all of these, for most like this unit test, you'll be allowed a calculator. There might be the odd, we might end up putting a part that's no calculator. So then we would include these types of questions, but we wouldn't include this one if you weren't allowed a calculator. So, you know, we'll make it appropriate for whatever situation you're given. So this will be 4 and then cubed root 2. Nice thing about graphing calculators, you can do them, they have a big screen, so you can do multiple operations and at once. And then actually, I'm gonna go like this. Yeah, so I gotta fix that. So I need to go, if I do this 6 times, then 4, there we go, 4th root of 5, and then 4 square root of 5. Okay, so they're all pretty close. Which one's the smallest? The first one's the smallest. And then the last one, and then the middle. Okay. And that's it. Okay, so that was a long lesson, but hopefully that gives you a good um, understanding of radicals and of how to simplify radicals with numerical radicands and variable radicands.